a function f of xy of degree n is said to be homogeneous if and only if given f of lambda x, lambda y is equal to lambda power n f of xy. A function is homogeneous of degree n if and only if when you are given f of lambda x, lambda y is given by lambda power n f of x y, whereby you can factor out lambda power n. That is now when an equation is said to be homogeneous, as we are going to illustrate in the example below. Consider this example here. If you have a function of x of y and you are given it to be 2xy squared minus s cubic plus 4x squared y, we are going to use this one to illustrate how we can determine whether this function is homogeneous or not. So first of all, what we are going to do, we are going to write it in this form here. So in form of lambda. So you have lambda of x, comma, lambda of y. So whenever you have x and y, you introduce lambda. So you have 2 into bracket lambda x multiplied by bracket lambda y, then you square that minus bracket lambda x, then you cube that plus 4 into bracket lambda x, then you square, we are substituting here, multiplying by lambda y. So that is the first step. The second step from there is you remove this bracket. So when you remove the bracket here, in this part I'm going to have 2. You have lambda squared, so you will get lambda cubic x y squared minus lambda cubic x cubic plus 4 lambda cubic, because of this lambda squared and this other lambda, x squared y. Now from there, now you can see here we can factor lambda cubic. Factoring lambda cubic outside, we are going to get the following. So lambda cubic can be factored to be left with the 2xy squared minus x cubic plus 4x squared y. Then from there, now you close the bracket. Now when you compare this with our original function, it follows that x equal to 2x y squared minus x cubic plus 4x squared y. F of x lambda, comma, y lambda is equal to lambda cubic into bracket, what we have found here, 2xy squared minus x cubic plus 4x squared y, meaning that f of x lambda y lambda, this can be written as f of lambda x, comma, lambda y is equal to lambda cubic into bracket or f of x y. Hence This function, which we are given here, is an homogeneous function of degree 3, degree 3, considering this power of lambda there. So we say the homogeneity here is of degree 3. Now the differential equation defined by the ordinary differential equation defined by this m into bracket x of y dx plus n into bracket x of y dy, which is equal to 0, is seen to be homogeneous, if and only if both m and n above are homogeneous and are of the same degree. So m, the function m, and the function of n must be homogeneous and of the same degree, so that this equation can be homogeneous. So example, let's say you are given this equation here, 2xy minus x squared dx minus bracket x squared, as take this as x power 3. Now the question is, you determine whether this equation is homogeneous or not. Now when you consider here, this is 2, this is 2, this is 3, this is 3. So m here as degree 2, n is this one, n degree 3. Hence, this kind of equation, of ordinary differential equation, is not homogeneous. Now, to solve homogeneous differential equation, we make the following substitution. So, to solve ordinary differential equation, we make this substitution. We let our y to be equal to vx. Then from here, we differentiate both signs. So, we differentiate both signs to obtain the following. So you get dy over dx. This is a product function. So here you are going to get v plus v plus x dv divided by dx. So that is the substitution we make when we want to solve a homogeneous equation. We make this substitution. We let y to be equal to vx, and then we differentiate both signs and we make the substitution. Now in the next video, I'm going to show you how you can solve and differential equation. Bye. Thanks so much for learning with me. Stay tuned so that you don't miss a single video which I upload for you every day. If you have not yet subscribed to this channel, kindly consider doing so that you don't miss a single video which I upload for you every day.